Hello students. Today we are going to start with a new topic, that's arithmetic progression. Yes, this topic is basically a common topic in all the curriculums, be it state board, CBSE board or ICSE board, even Cambridge, IGCSE and IB as well, right? So it's one of the important topics which is common for everyone and quite interesting. Once you know the formulas, once you know how to solve it, it's going to be very easy, right? So let us start. Right. So what do you mean by arithmetic progression, right? Arith means related to numbers. Progression means something which is moving on. So when you combine together arithmetic progression, that means numbers which are moving on, right? Numbers are moving on. But when numbers go on either increasing or decreasing, and when they are bound by some rule, right? When they are bound by some rule, that type of progressive numbers is called as arithmetic progression. So if you want to define an arithmetic progression, it says an AP. AP means arithmetic progression. What is it? It is a sequence or series of numbers in which each term can be obtained by adding a certain quantity to its preceding term. Like for example, if I say 1, 2, 3, 4, 5, dot, dot, dot. What is the difference between 1 and 2? So this can be your first term. This is your second term. This is your third term, fourth term, fifth term, and so on. So the difference between this is the succeeding term, 2 is the succeeding term, 1 is the preceding term, right? So difference between the succeeding term and preceding term is 1. Similarly, when we see difference between 3 and 2 is 1, 4 and 5, it's again 1. Right? So this is called as common difference. So when the difference, or when I say to the preceding term, when I add 1, I'll get my term 2. So in the first term, if we add 1, I will get my second term. To the second term, if I again add 1, I will get my third term. To the third term, I will again add 1, I will get my fourth term, and so on. This will go on, right? So this is the way your arithmetic progression will proceed, right? So the next example I'll give you, let's say a progression of all the odd numbers. So let us start with 1, 3, 5, 7, 9, and so on. So when you say difference is again 2, difference is 2, difference is 2. So over here, your first is the first term, and number 2, that's the difference, that's the common difference. See, unless and until there is not a common difference, that sequence of numbers, it will not be an arithmetic progression. Right? For example, if I say, I have 1, or let's say 7, 8, 10, 13. Okay, the numbers are proceeding, right? But is there a common rule? Over here, the difference is 1 between 7 and 8. 8 and 10, the difference is 2. 10 and 13, the difference is 3. So there is no common difference. They are not bound by a certain rule, right? So there is no common difference between them. Hence, it won't be called as an arithmetic progression, right? So a series of numbers which is obtained by adding a certain quantity to the preceding term is called as arithmetic progression, right? So these are some examples. So let's see, I have 1, 4, 7, 10. So that means 1 plus 3 will give me 4. 4 plus 3 going to give me 7. 7 plus 3, 10. 10 plus 3, what I'll get? 13. 13 plus 3, 16. 16 plus 3, 19, right? And so on. It will move on. 6 plus 6, 12. 12 plus 6, 18. 18 plus 6, 24, 24 plus 6, 30, 36, 42, 48, and so on, right? 3 plus 0, again 3. So what are we doing? We are adding 0 here. So 0 is a common difference. Yes, 0 can be a common difference. So again 3, 3, 3, 3, and so on. Now, what are we doing over here? See, 4 into 4, 16. 16 into 4, 64. We are multiplying. Is this a AP? Yes, this is a AP. This one is also AP. When we add 0, this is also a AP. But now what is happening in this fourth one? Now multiplying by 4 and you're not adding 4 to it, right? So when you multiply anything, that can you see the common difference? If you check the common difference between two terms, it is not constant. It's not same, right? So this won't be an AP. Not an AP. It's not an AP, right? So you can just fill up by multiplying 4, 4, 4, 4, right? That's not a problem. Now, if you see over here, the fifth one. So the first term is minus 1. Plus of minus 5. So you get minus 1.5, minus 1.5, plus of minus 0.5. So you're adding minus 0.5 to every term. So when you add minus 0.5 to every term, yes, it is a AP as your common difference was same, right? You're adding the same quantity, be it positive, be it negative, be it 0. Common difference can be anything. Okay, so yes, this is a AP. Okay, so minus 0.5, this will be minus 3. Okay, so let's proceed. Now, so an arithmetic progression, what is it? It's a list of numbers in which each term is obtained by a fixed number to the preceding term except the first term, right? The first term will be any number. Now to this number, you're adding a specific quantity, you get the second term. To the second term, you add a specific quantity, you get the third term, right? So your first term is always, so when I say I have an AP, so that AP is T1, T2, T3, T4, and so on. These are the terms of AP. See, some textbooks say T1, T2, T3, T4. In some textbooks, it is A1, A2, A3, A4, right? So do not get confused. So now when I say T1, T1 is always your first term. T1 is always your first term. So first term will always be A. First term is always A. Now how will I obtain the second term? To the first term, so it will be T1 plus A. To the first term, I'm adding a D. What is D? D is the common difference. Then only I'll get my second term. So this is A plus D, right? Now how I'm going to get my second term? This will be A plus D. Right? Then we have a third term. So the third term is second term plus D. Second term plus D. So this is equal to, what is your second term? Your second term is this, A plus D plus D. So can I write this as A plus 2D? Right? So T4 is T3 plus D. T3 is what? T3 is this, A plus 2D. Again, plus this D. So this is going to be A plus 3D. And this will go on. Right now, so these are the terms in an AP. The terms in an AP will be of the form A plus D, A plus 2D, A plus 3D, A plus 4D, and so on. So this will be your first term. This can be termed as A1. This will be your second term, A2, third term, A3. See, again, I'm telling you, some textbooks give it the name of A1, A2, A3. Some textbooks give it the name of T1, term 2, term 3. This will be term 4. This will be term 5, T5, and so on. So that does not make a difference at all, right? Okay. Now, there are certain characteristics of D. Okay. So as we saw initially, D can be positive. When we add a positive term, yes, D can be. So characteristics of D can be a positive number, right? D can be a negative number. We saw in that example. D can, in this one, right? Here D was negative. D can also be 0. Okay. D can also be equal to 0. D can be a fraction. D can be a fraction. D can be a decimal. We added minus 0.5 in that particular example, right? So D can be in these terms. D can be a positive number, a negative number. It can be a 0. Okay. It can be a fraction. It can be a decimal. D can be anything. The only thing is, it should not be an irrational number. It should be a rational number. And how will you get D? D is always the succeeding term minus the preceding term. So if I have, for say, so D can be T5 minus T4, or you say A5 minus A4, succeeding minus preceding, T3 minus T2, let's say A3 minus A2, and so on, right? In this way, you can find out D. Okay, so now, as we saw over here, these were the general terms. These were the terms in an AP will be of this form. Okay, so now we come down to general form of an AP. Now, one more thing to tell you over here, that AP can be of two types. One is a definite AP, and another is an indefinite AP, or we also call it finite AP or infinite AP. Okay, so finite or infinite, right? So when we say finite, it has a fixed number of terms. So I say that there are 10 terms in a particular AP. So yes, n. What is n? N is the number of terms. Okay, when I say a fixed number, that n is equal to 10. So yes, it is a finite AP. But when I say there is nothing specified, the AP goes on. And normally when the AP shows, like for example, 2, 4, 6, 8, 10, these ... that means it is an infinite AP. What is this? This AP is of even numbers. Common difference is D equal to 2, and your first term is also 2. Right? So these were something related to AP, and now we come down to the general form of an AP. General form of an AP, I have told you earlier as well. So it is, the first term will always be A, second term will be A plus D, the third term A plus 2D, fourth term A plus 3D, fifth term A plus 4D. So over here I'll write T1, T2, T3, T4, T5, T6, A plus 5D, and so on. So now according to this, we will then come down in the next class, we will come down to a general form for an nth term, for a nth term of an AP. For example, suppose A and D is given to you. Right, the first term and the common difference is given to you, and they have asked you to calculate the 100th term. So it is actually not possible for you to keep on adding D and get the 100th term. We need to have a general form for that, right? So the general form of an AP, if you see over here, according to this, if you see, the number which is associated with D is 1 less than the number of term. That means, for example, example only I'm giving, okay? Example, if I say T4, what is T4? A plus 3D. So which is equal to A plus, what is 3? 3 can be said as 4 minus 1 into D. So instead of 4, if I keep the nth term, the general term of form for an nth term, so let's say Tn, or in some books it's given as An, is equal to A plus n minus 1 into D. Yes, this is the general form. What is general form of an nth term? An is equal to A plus n minus 1 into D. all these terms are in the same form. If you see, this is 3 over here. Now 3 is 1 less this 2. Okay. 3 minus 1 into D, 4. 4 minus 1 into D, that's 3. 5. 5 minus 1, that's 4D. 6. 6 minus 1, that is 5D. Okay. So this is the general form of nth term of an AP. Right. Hope you have understanding. Now let us do some questions based on the introductory concept. What is an AP and what forms an AP? So check whether they are AP. If they form, write the next two terms. So let's see the first one. What is the first one? 4, 10, 16, 22. Okay, so 4, 10, 16, 22. What is the difference? 10 minus 4, 6, 16 minus 10, 6, 22 minus 10, 6. Okay, so you're right. As D is constant, yes, it is a AP. This is one form of writing it. Another form, let's say, let's do the second one. What is the second one? 1 minus 1 minus 3 minus 5 and so on. So your T2 minus T1. So what is T2 minus 1 minus T1 is minus 2. T3 minus T2. What is T3 minus 3 minus of minus 1. So that's going to be minus 3 plus 1, which is minus 2. T4 minus T3. What is T4? Minus 5 minus of minus 3. So that's going to be minus 5 plus 3, which is again equal to minus. So what are we doing here? We are checking the D. So again, as the common difference, D is constant. Yes, it is a AP. So this is also an AP. This is also AP. Now look at the third one. The third one is minus 2, 2, minus 2, 2, minus 2, 2. So let's check for the third one. T2 minus T1. So it will be 2 minus of minus 2. That's going to be 4. T3 minus T2. Again, minus 2, minus 2. That's going to be minus 4. 2 minus 2 again plus 4. So it will be 4 minus 4, 4 minus 4. So this is not constant. So hence it is not an AP. Fourth one, 1, 1, 1, 2, 2, 2, 3, 3, 3. So obviously it's not proceeding in a particular manner. This is not an AP. Right? So now let's see the next one. In which of the following situations does the list of numbers involved make an arithmetic progression and why? Right? So see, in arithmetic progression, number related questions are coming, but application related questions will also come. Applications as in, see, a situation is given, you need to see what series of number it makes. And if it makes, I mean, if the series of numbers which is there, if it's an AP, we need to specify it, right? So over here, the taxi fare after each kilometer, when the fare is rupees 15 for the first kilometer and rupees 8 for each additional kilometer. Now, there's a taxi fare. For the first kilometer, he's charging you rupees 15. For every kilometer which is traveled after the first kilometer, plus 8 rupees is added. So for the second kilometer, it will be 15 plus 8. For the third kilometer, it will be 15. So 15 plus 8 is going to be 23. 15 plus 8 plus 8. So that's going to be 23 plus 8. It would be 31. For the fourth kilometer, it would be 31 plus 8. So that's going to be 39. So if you observe 15 and 23, common difference is 8. 23 and 31, 8. This is also 8. So as it is being added by 8 with each succeeding kilometer, yes, it forms a AP. The amount of air present in a cylinder when a vacuum pump removes 1/4 of the remaining in the cylinder. Now see, the second one, you have a cylinder. Every time you're removing 1/4, okay, what is remaining in the cylinder? For example, the cylinder is fully filled. I'm removing it for the first time. That means I have removed 1/4 of this. And now how much do I have? I have 3/4 remaining. Now, out of this 3/4, 1/4 is removed. Now, out of the remaining, again, 1/4 is removed. So if you see the base amount is going on decreasing, this will not form an AP, right? This won't be an AP at all. The third one, the cost of digging a well after every meter of digging, when it costs rupees 150 for the first meter, rises 50 for each subsequent. This is same as your taxi fare. So for the first meter to dig, they cost rupees 150. And after 150 for each meter, they are putting plus 50. For this third meter, again plus 50, again plus 50. So 50 is your common difference. Yes, it forms an AP. Fourth one, the amount of money in the account every year when 10,000 is deposited at compound interest of 8% per annum. You have learned in 8th standard, compound interest is always on the, not on the base amount, but on the accrued amount. Like for example, for the initial first year, you have deposited 10,000 rupees, right? So it is for the, after, at the end of first year, you will, it's at 8%. So 800 rupees will be added to it. So it's 10,800. Now for the next year, your amount will be 10,800 and not 10,000 itself. So 8% of 10,800 would be added at the end of second year. So the compound interest never forms an AP. Simple interest forms an AP, right? So the first and the third one is an AP. Second one is also not an AP, and compound interest is also not a AP, right? Okay, let's proceed with certain number related problems now. What do they say? They are saying which of the following are AP? If they form the AP, calculate the common difference and write the next 3 terms. I'll do some for you and some you can practice them as assignment, right? So if you see the first one, 2, 4, 8, 16. So 2 to 4, 2, 4, 8. Here only it's negated, does not form an AP. The second one, it says 2, 5 by 2, 3, 7 by 2. So now let's see for the second one. D is 5 by 2 minus 2. What is 5 by 2 minus 2? So for take an LCM. So this will be 5 minus 4 upon 2. So that's 1 by 2. Let's take the D for the third and the second term. So D 3 minus 5 by 2. 3 to the 6. 6 minus 5 upon 2. Again 1 by 2. Right. Now let's check for these two as well. Again D 7 by 2 minus 3. So this will be 7 minus 6 whole upon 2. So again 1 by 2. Yes, as D is constant, this is going to be an AP. So now how will you find out the next 3 terms? So therefore now here this is 4th term. So till T5. So T5 or you say A5 will be equal to, what is the 4th term? It is 7 by 2. So it will be 7 by 2 plus 1 by 2. So that's going to be 8 by 2, which is going to be equal to 4. Next 3 terms they have asked us. So T6, that is A6 will be A5 plus D. So what is your A5? So 4 plus 1 by 2. 4 plus 1 by 2 will be 9 by 2, right? T7 or A7 will be again A6 plus D. So that is 9 by 2 plus 1 by 2. So that's 10 by 2. That is equal to 5. So the next 3 terms of this AP is 4, 9 by 2 and 5. So in this way you need to proceed, right? See, minus third one, minus 1.2, minus 3.2. So 2 is the difference. Minus 2, 5 minus 5.2, minus of minus 3. So minus 2 again, minus 2. Yes, it forms an AP, and the common difference for the third one is minus 2. Fourth one, minus 10, minus 6, minus 2, 2. So minus 10 plus 4 is minus 6. Minus 6 plus 4 is minus 2. Minus 2 plus 4 will be 2. Fourth one also forms an AP. This is an AP, this is an AP. And if when you know the D, you just keep on adding the D to the preceding term, you'll get the next term. If you see here, the fifth one, 3 plus root 2. 3 plus 2 root 2. Root 2, root 2, root 2 is being added. Yes, it is an AP. 0.2, 0.22, 0.222. Let's check for this one, sixth one. It says 0.22 minus 0.2. This will be 0.02. Okay, this is the first D. So now the third, 222 minus 22. 2, 0, 0. No, this is, so when you keep on subtracting, it says 0.02 for the first D, 0.002 for the second D. But for the third D, it will be 0.0002 for the third one. So it does not form an AP over here. Seventh one, minus 4, minus 8, minus 12. Yes, you're adding minus 4 to it. So seventh one is an AP. Minus 1 by 2, minus 1 by 2, minus 1 by 2. Same term when it goes on getting repeated again and again, that will also form an AP. Why? Because over here, D is equal to 0. Yes, it forms an AP. The ninth one over here, 1, 3, 9. So no, it's cube going on. No, this is not an AP. A, 2A, 3A multiplied by 2 multiplied by 3. Again, not an AP. No, just a minute. For this one, if you see for this one, so it is 2A minus A, I'm going to get A. 3A minus 2A, I'm going to get A. 4A minus 3, I'm going to get it. This forms an AP. Root 2, root 8, root 18, root 32. So root 8 minus root 2. So what is root 8? 4 root 2, right? 2 root 8 is 2 root 2. 2 root 2 minus root 2. So let's see for the next one. For this one. This is root 8. What is root 8? Root 8 is 2 root 2. This is your second term, P2. Minus root 2, the first term. So if I 2 root 2 minus root 2 will be root 2. What is root 18? T3 is root 18. So root 18 is basically 9 2s are 18. So root 9 will be 3 root 2. 3 root 2 minus 2 root 2, again root 2. Then T4 is root 32. Root 32 is basically 16 2s. So 6, what is 16? 16 is 4. 4 root 2 minus 3 root 2. Root 2. Yes, see, though they won't look like, but again, you have to check the D, because as D is equal to root 2, that's coming out to be constant. Yes, it is a AP, right? 1 square, 3 square, 5 square, 7 square. 1, 3 square is 9, 5 square is 25, 25, 7 square is 49, not an AP. Self looks, it's not an AP. Okay, right. So this is the way you have to check whether a given series of numbers is an AP or not. Does it form an AP or not? If it forms AP, it is very easy to find out the first term, that is A, and the common difference D, and then find out the successive terms, right? Such types of questions are going to come. Now, 2 things to remember in a sequence C. If the difference, that is n plus 1 and n, that means the succeeding term minus the preceding term, is a constant, then the sequence is called an arithmetic progression. In an AP, the difference between 2 consecutive terms is always denoted by D. What is D? D is the common difference. As I told you, D can be positive, negative, 0, decimal, fraction, anything. Only thing is it has to be common, right? Then in an AP, if the first term is A and common difference is D, then the terms in an AP are of the sequence. We have already discussed this: A plus D, A plus 2D, A plus 3D, A plus 4D, and so on, right? So this is the way the terms will go. Right, so this was the introductory part of arithmetic progression. Now next class we will be doing with the general form of a term of an AP and solve many questions based on this thing, right? Hope you have understood. Any doubts are there, please let me know in the comment box. Okay, I'll get back to you soon. Thank you. Bye-bye.